We're going to review this idea of order of operations because it's really important that you know the rules when you're trying to calculate a more complicated expression like the one that we have here. If you're not doing your operations in the correct order, you're going to end up with the wrong conclusion and the wrong answer. And students use a variety of tricks to help them remember the order of operations. You may have heard about PEMDAS or GEMDAS, and I'll explain that in a minute, but I want to kind of give you a little bit of background as to kind of what's even behind that idea. Now, the order of operations has a lot to do with the terms in your expression. And terms are all of the pieces that make up a larger expression. The terms in an expression are separated only by addition and subtraction. Multiplication and division is they're kind of sticky operations in that they sort of stick numbers together. They sort of group numbers together. So addition and subtraction are the only things that really separate terms. So let's kind of figure out how many terms are in this expression. So how many subtraction and addition signs can you identify here? I see 2. Okay, now it's really helpful to get into the habit of circling or putting a box around your terms so that you can visually kind of see that separation a little better. So my first term here is this 16. That 16 is just hanging out all by itself, and it's separated from some other stuff through subtraction. So that is a term in and of itself. My next term is going to be all the stuff that's in the middle between my subtraction and addition. So that's my second term. And then my last term is going to be this little 5 hanging out there by herself. So in this entire expression, there are 3 terms. Now, in order to properly calculate, I need to deal with all of the terms. I want to get all of the terms as short. I want to shorten them as much as possible, essentially kind of trying to rewrite them, get them down to the single number that they represent. Then I can do all that subtraction and addition very last. Okay, so let's start to look into what I got to do for this one. Now, oftentimes within your terms, there's a lot of stuff going on, and you have to keep in mind what the correct order of operations is. So GEMDAS, again, that's something that's helpful to a lot of the students. So I'm going to kind of go over that right now. The G in GEMDAS, you may or may not remember or have learned this, but that represents any groups. And those are signified by particular grouping symbols, parentheses, brackets. Do you see any grouping symbols in this expression? There really aren't. No parentheses, no brackets, anything like that. The E in GEMDAS, that stands for exponents. Do you see any exponents in any of my terms in this expression? Well, yeah, there is this little one here, okay? So we'll come back to that in a second. The M and the D, that is your multiplication and division. Oh, I already have a D there, so I don't need that. So multiplication and division. After you deal with your grouping stuff in groups, after you deal with exponents, then you can start doing any of the multiplication. And we always go from left to right when we're dealing with any of that. And then finally at the end is our addition and subtraction. Not only within a term, but across the whole expression. So the terms, once we have the terms down to, all of the terms down to a single number, then we'll go ahead and carry out all that addition and subtraction also from left to right. So focusing on my G and my E, there aren't any parentheses, but I do have an exponent. And an exponent is really just multiplication, right? The 2 to the 3rd power means 2 times 2 times 2, which is 8. So now I have, basically in the middle there, I'm really looking at 8 divided by 8. Well, 8 divided by 8, now that I've taken care of my exponent, I can carry out this division. And 8 divided by 8 equals 1. So this term in the middle here is really just 1. Now that I have all of my terms down to a single number, the 16 is just a 16, that stuff in the middle is just 1, and the 5 is just a 5, now I'm going to look at all addition and subtraction going from left to right. Starting at the left is my subtraction. So I'm going to do the 16 minus 1. 16 minus 1 is 15. And now I'm going to add that to the 5 at the very end. So 15 plus 5 is 20. And that is my final answer. Okay? The multiplication, division, and the addition and subtraction, when you go to focus on that stuff, addition doesn't come before subtraction, it's just that you do both of those things going from left to right. And with multiplication, division, multiplication doesn't come before division necessarily, it's just however it goes moving from left to right. So now let's try one more example. First thing I want to do is identify my terms. And remember, terms are separated by, that's right, addition and subtraction. So how many subtraction symbols or addition symbols are in this expression? I only see 1, which means this 20 is a term by itself, and all this other stuff belongs to one term. Because remember, all that division and multiplication is sticky. It's sticking all that stuff together. The subtraction is the only thing that's separating the terms. So here I only have 2 terms. Now that I've identified those terms, I want to try and get that term on the right down to a single number. I want to evaluate it and do all the calculations I can so that I get it as short as possible down to a single number. And I do want to follow my correct order of things. So, do you see any grouping symbols in this term? I do. I see a set of parentheses. So we're going to focus on what's inside the parentheses first before anything else. Now, inside the parentheses, I see a couple things going on. I see exponents, an exponent, and I see a division symbol. But what are we going to have to deal with first? My exponents, because exponents come before the division. And exponents, by the way, as we talked about earlier, it's really just like multiplication. So let's kind of take care of that. 3 times 3 times 3 is 27. So essentially what I have inside my grouping symbols is 27 divided by 9. 27 divided by 9 is 3. So all that stuff in the parentheses is equal to 3. Now that I've taken care of that group, now I'm going to look for any multiplication and division going from left to right. Well, I really just see some multiplication there. 3 times 2 is equal to 6. So this entire term is really just a 6. I don't have any division. So now that I've gotten my terms down to a single number, I'm looking at 20 minus 6. And I'm going to take care, I don't have any addition, but I'm going to take care of the subtraction now, and that ultimately gives me 14. So this entire expression comes down to 14.